So we're doing the quiz prep right now. We're going to finish up those 4 examples from 4.4 at 11:35, and then whatever questions you have, I'll go over whatever questions you want. At 11:35, we're going to do the quiz. Now, the quiz, I'm going to write 3 problems just like that on the board. Copy. You're going to take out a piece of paper like the good old days, write them down, put your first and last name on it. We're going to do it that way. Okay. I will not accept binder paper with frayed edges. So if you have binder paper with frayed edges, I have a piece of printer paper for you to do it instead. My dogs have a belly full of little edges, you know. They go on the floor. My dogs think it's popcorn. I don't know. They're dumb. I mean, their names are Flick and Bubbles. I mean, how smart can those? That could be a bonus question on a test, you never know. Flick, Bubbles. Okay, quiz. It's going to post today, the final focus. What that means is there's not a review sheet for the final, but there is if you want to call it a review sheet, it's a bunch of multiple choice types of questions so you can practice multiple choice types of questions. I think I went over this on Monday. There's a 32-page version of it. There's a 16-page, same thing version of it. So one is, and I'm going to show you, it's 2 pages on one, so it's half the size. And the other one is 1 page per 1 page. If you're going to print it out, you might as well just print out the shorter version. I think like 7 of the pages are just the answers. Okay, because there's like 100 something questions. Your final, I don't know, I haven't written it yet, but it's not going to be more than 40. But it's a chance for you to practice the entire semester's worth of questions in multiple choice form. Okay. Next Monday, we review. And I will go over whatever you want to go over, whether it's from the final focus or if it's from the chapter 3-4, whatever you want to see, you can ask. And then on Wednesday, chapter 3-4 homework is due, and we take the chapter 3-4 test. Following Monday, last day, fall final, it starts at 10, it ends at 11:50. It ends at 11:50. There is no, I'll let you go until. There's no. Either class comes in at noon, starts their fine. Okay, that's why it starts. You're not turning anything in. So there is no, the reason why I let some people go, finish at 12 is because I take a long time to go through the homework and say, all right, I took 10 minutes at the beginning of class to check all the homework. I'll let you go an extra 10 minutes past that 11:50 because I took that time. But with this, you're not turning in the homework. Don't be late because you lose points if you're late. You'll need this Scantron 882-E and a number 2 pencil. And like I said on Monday, she has them. She'll sell them for, what do we say, $3? But she has a few that she can barter, trade, or even maybe generous. I don't know. I'll just let you know. Beg, please, borrow, maybe steal. Okay. You need a distraction. Okay. Very part of the machine. Okay. Finals week. There's no co-rec. The last co-rec when we meet will be next Wednesday. And again, anybody can always come into the co-rec. We'll be reviewing for whatever they want to review for on Monday and Wednesday. That's all we're doing next Monday and Wednesday, and also Tuesday, Thursday, yeah. Co-rec meets 8:30, Monday through Thursday. Finals week, they don't have a final, so it's just extended office hours starting at 7:30 to 9:30. Okay. There's no office hours this Friday. It's holiday. I'm gonna sleep then. Okay. Any questions? The only thing we have to do is calculator problem from 56, 62, and 68 that we didn't do on Monday. And then I thought we might have done 104. I don't think we did 104. It was at the end, so do 104. It's not that long. All right. Please. Usually Tuesday, Thursday gets the benefit from this phrase. Don't do what Monday, Wednesday did. Because you usually take the quiz before they do. So I get a chance to look at your quizzes. Maybe I've graded it, maybe I haven't. But then I have an idea of mistakes that happen. And I might say to them, oh, you know what? Please make sure you don't do this. Well, they took theirs yesterday. So I'm going to tell you, please don't do this. First off, I'm not even going to put the calculator up yet because I have to see. And they, at least they did this. They listened to this part. I have to see the substitution and the simplification before you punch it into the calculator. Okay? So we're going to evaluate f of 9/10 and we're going to round to the nearest thousand. So we're going to replace x with 9/10. So when you rewrite this, f of 9/10, we're going to get -4 times e to the 5/3 times, now this is where they had a quiz prep. They saw an example of it. They got to use notes. I know I'm picking on them, but I pick on you when I go through their quiz prep after you take it. They're supposed to replace x with 9/10. Now, what I was seeing them do was -4 e to the 5/3 x and then a 9/10. I don't know if they meant that as a times as an x, or they just had the x and then a 9/10. It wasn't clear. You substitute, replace the x with a 9/10. So it's not clear to me what that actually is. It looks like they just left the x in there. First of all, we don't use that symbol for multiplication once we get past arithmetic. Parentheses, or 5/3 times 9/10. Because we need that symbol of multiplication that we learned back when we were in the first grade to represent an x as a variable. And we don't want to get them confused. Okay. Second of all, I told them, make sure that you write it as a superscript so we don't confuse it with multiplication. So it needs to be up here as an exponent. And I was seeing -4 e 5/3 and then 9, like 9 and then 10. Or not even the e. They just have a bunch of numbers. So they're not writing the problem as you go from left to right, then bring it down from top to bottom. Maybe they wrote it in like this, but then they're over here going, like, I'm like being overly dramatic with the messing. They're doing the 5/3 and the 9/10. And they're trying to work this piece out. And then they're coming back over here. And this works out to, let's just say whatever. And they go -4 times this answer, and they don't bring the e with it. So it's like, I want to build this bookcase. So I'm going to cut the shelves into the right length and width and depth. But I'm going to go cut them over here across town, nowhere near the actual case itself, and then I'll bring them back and hope they fit. Hope. Hope has nothing to do with math. Hope does not solve math problems. Okay? consistent. You have to be direct. You have to be neat. You have to be clean about it. -4. E. Simplify the fraction. Whether you multiply then reduce it or just reduce it. This would be, if I just multiply, this would be 45 over 30. Now, if you reduce it, the common factor is 15. This is 3 times 15 over 2 times 15. So it's e to the 3 over 2. I want to see that. I want to see this written out before you punch it up on the calculator. I want to see the substitution, the simplification, and then we'll punch it in. Or -4e 5 over 3 times 9 over 2. 5, 9 over 10. Going straight to the answer. 5 goes into 10 2 times. 3 goes into 9 3 times. So I'm left with -4 times e, and I'm left with a 3 over 2. And I can reduce it before I multiply. But at this stage of the game, at this stage of mathematics, we have to be able to reduce fractions. Whether you multiply then reduce it or reduce it before you multiply, you have to be able to deal with the fractions. Fractions are not going away, ever. You run into more fractions than likely you do with integers anyway. Okay. Now we're going to punch this in. And you got to make sure you write it as a superscript. That's another reason why you're going to get something that's going to have a fraction. I want to see you pay attention to the detail. So now when we punch this in, if you want to punch it in all at once, I'm not going to take any points off of that. But makes you nervous, then just do this. Do the E first. It's going to be, if you do this, f of 9 over 10 equals, bring down the -4, and let's see what this equals. E to the 3 over 2. E is right here. It's the second function for natural logarithm. E is the base of the natural logarithm. So it's in blue right here. It's the second function. To operate or to set up the second function, you have to hit the second key. Second, and then E to the X. So second, and on your calculator, you should see E to the X. E to what? I want to go E to the 3 over 2. So parentheses is already set up. 3 divided by 2. Close the parentheses. So that's 4.48. So this part is 4.48168.907. I know you're going to round to the nearest thousand. If you want to only write down to the nearest thousand here, that's fine. If you want to round that and put only 4.482 right here, that's fine. But when you actually do the calculation, use the number that's in the calculator. So that way you have an accurate answer. Don't just multiply times this that you rounded ahead of time. Use the actual answer, because if you're going to round to the nearest thousand, you need to know it's in the 10,000s place. So if you round too early, it could be off. So that's why I get paranoid about rounding too soon. So the final answer is going to be, or the almost final answer is going to be -4 times this. So now I'm going to multiply by -4. I don't need to punch in a -4 on my calculator to multiply. The answer is going to be positive or negative. It's going to be a negative. A negative times that positive, I know my answer is going to be a negative. So on my calculator, I just need to multiply by 4. That way I don't have to worry about hitting -4 times that, and I don't have to worry about, do I press this minus or this negative? You would press this negative, by the way, -4 times that answer. Don't press this, you press this, you're going to get an error. But I'm just going to multiply by 4. And it doesn't matter. I can go 4 times this answer. I can go 4 and then times, and then I go second answer. And would give me the answer, or delete that. If I just hit right here, just go times, oops, you're so close. If I go times, it takes the last answer in the calculator. I don't have to type it back out again. The last answer I got in the calculator, and then go times 4. Okay. So my negative is already there. The answer is going to be -17.92675,628. The nearest thousandth is the third decimal point, tenths, hundredths, thousandths. So it's going to round up to a 7. -17.927. F of 9/10 is -17.927. I want to see the substitution. I want to see that exponent simplified. And then from there, you get a decimal answer. On a multiple choice test, there's going to be 4 decimal answers. I don't write multiple choice tests. I can't come up with 4. I can't come up with 3 wrong answers and 1 correct one. I can come up with the correct answer. But when basically the textbook that generates those multiple choices, they always generate an answer that's wrong using a common mistake. They will do it as if they know exactly what mistake somebody's going to make. Basically, hey, you've done it on your own, and the answer that you got is right there in front of you, but you did it wrong. And it's waiting for you to go, oh, yeah, that's it. Or it's really close to the one I got, so I'll just choose it. Those are called distractors. That's how the SATs work. Any questions on it? You know what I'm looking for? That's exactly how it will look. It will be an E. You calculate it. And then number 2. Rewrite in exponential form. You have log base 64 of 1024 is equal to 5/3. So we're just going to convert that into an exponent. Base of the across equals what's inside. That's all you got to do. What's the base? 64. So base 64 to the what? To the across is 5/3 equals what? 2024. Done. So base to the across equals what's inside. That's all. You don't do anything else. That's it. All I want to see. Now, how do you lose points? Because if you like 64 to about 5/3. You don't lose a lot of points, but that's not 64 to a power. That's 64 times 5/3. And I've gone over that. I've made a big deal about it. That'll be written at the next one. Base to the across equals what's inside. Any question on that? And rewrite as a logarithm. So you're given an exponent, e to the 3x equals 340. So you want to write it as a logarithm. So we're going the other way. So somebody took our log base something of something equals something over here and did base to the across equals what's inside with it. What's the base of that exponent? What's the base? E. So it's log base E, base to the across. So what's the power? So base to the across. The 3x is the across. Base to the across. Base to the across. So the 3x is the across. Base to the across equals what's inside. Base to the across equals what's inside. So the 340 is what's inside. Now here's this is where I took off points on them. So they wrote their final answer, log base E of 340 equals 3x. And I said, no. When you're given base E, you need to use natural log notation. When it's base E, it's a natural logarithm. So the natural log of 340 is equal to 3x. That's the correct notation for base E. And one way to remember, it's on the calculator. Right above the ln button is e to the x. Okay. And I was seeing all sorts of crazy things. I was seeing like natural log of to the 340 power. That's not 340 in the logarithm. Honestly, I don't know what that is. I think they thought there had to be an exponent somewhere, so they put something somewhere. Or I saw natural log of 340 equal e to the 3x. Well, you can't have an e to the 3x in your logarithm end. So you're saying that e to the 3x, which is 340, is also equal to the natural log of 340, which means the natural log of 340 is equal to 340. Since they're both equal to e to the 3x. That can't be true. So they have e to the 3x on everything. And that's just that process of I'm trying to put everything everywhere instead of one thing at a time. I want to put all the spices in the soup and not the right spices. I'm trying to make it up. I know I got a little bit of this, a little bit of that. And when do I stop? I don't know. If it doesn't look like something we've been doing, maybe you shouldn't be doing it. Maybe you should ask instead. Keep saying. Any question? Last quiz. Three questions, 5 points apiece, 15 total. And I keep saying 10:35. 11:35. Those last four questions, the reason why we didn't get a chance to finish those is because the time it takes to actually do the calculator portion. It's not that they're difficult, it's because it takes a while to crunch it down in the calculator. So 56, 62, 68. I think you're doing 55 through 55 to 67 every other month. So you're doing 55, 59, 63, 67. Six to the 5x equals Andre 3000. That's about as current. That's my reference to musical living. Solve the exponential equation algebraically. In other words, what does x equal no decimals? Find the exact value. Then we're going to do it to 3 decimal places. Use a graphing calc. You don't have to graph. You don't have to do that. The third page of the review sheet. Third page of the review sheet is the properties of logarithms. Okay. So these properties, which are basically, you set these up, and these are your nice readings. If you recognize these, they change the problem to 10, 15 seconds rather than 3 or 4 minutes. And then in order to solve equations, sometimes you're going to be using these, but number 3 is incredibly important. And then you can change the base right there. To solve for x, x is an exponent. 6 to that power. We can't use division or anything because it's a power, not multiplication. So to undo that exponent, we got to bring x down from that exponent, down from the power. The only way to do that is this rule. Come on down. That Price is Right property. So since the calculator, and that's what they want is a decimal answer. Since the calculator only does base 10 or base E, yes. Okay. You got to make a choice. We want to take log base 10 or log base E of those sides. Have to make a choice. Okay. Yeah. Base 10 or base E? 10. So we're going to take the common log of both sides. You just go log this side, log of that side. So what happens now is 5x is down in front. It's 5x. Write it in blue. That's 5x times the log of 6, log base 10 of 6, common log of 6, and that is equal to So common log of 3,000. It's now a multiplication problem. Remember, we're solving for x. And the whole thing is about solving an equation is you want to undo what's being done to the x. X is now being multiplied by 5, and it's being multiplied by log base 10 to 6. So to undo what's being done, you're going to divide both sides by 5, and you're going to divide both sides by log base 10 to 6. Here, 5's reduce, log base 10 to 6 reduces, I'm left with x by itself. The exact answer is the log of 3,000 over 5 times the log base 10 to 6. But we want a decimal. Okay. Now, I want you to kind of, my calculator doesn't operate as nicely as some of the ones that you have. I cannot scroll up and hit enter and it will just paste whatever I, hit enter on back into the register and type it in for me. Okay, I can't do that. So I'm going to type mine in a little differently. You need to operate your calculator, figure out how you're going to best do your problem. The bottom line is, if you write it down as you do the problem, that allows me to figure out if you get the right answer, what you did. If you don't get the right answer, where's the partial credit? What did you do? So what I'm going to actually do first is I'm going to go, this is 5 times, I'm going to get this decimal. We'll see why I do this in just a minute. So the log of 6, common log of 6 is 0.778 15125 and I'm going to go another step here. I'm going to go common log of 3,000 divided by, I'm going to multiply this by 5. So times 5. See, all I had to do was hit times. I just hit, I don't even have to hit answer. I go times. And up pops answer times what? Times 5. So it takes the last answer and multiplies it by 5. And I get down here, I get 3.89075652. So x is equal to. Now I just want log of 3,000, common log of 3,000 divided by that number. So what I'm going to do is I'm going to type in log of 3,000, and I'm just going to hit divide by that answer. I'm going to hit common log of 3,000, and then I'm going to hit divide, and then I'm going to type in answer. Because it's already got that decimal in there. Otherwise, I'd be retyping things and having to type in decimals, and I don't want to round anything. And I don't want to type in all those numbers over and over again because I don't trust my eyesight. I don't trust the fat fingers mashing on the keyboard either. I'm a one thumb text her. And if somebody's talking to me while I'm trying to text, that's when I get in trouble with my wife because she cannot. It's like, I am trying to send a text for the last 30 minutes here. I can't see the dang thing, and my thumb is so fat it keeps hitting the space bar when I try to hit the M. And they're just doing this. I'm like, okay, sorry, but forget you. I hate it. So I just go log 3000 parentheses, and then I go divided by the last answer, second, and then right down here in blue it's an ANS answer. So it's going to take the log of 3000, divide by that answer, and we get 0.893. Six, eight, seven, 7639. The directions want 3 decimal places. So that would be the nearest thousand. So x is equal to 0.894. Now, according to the question, 6 to the 5x is supposed to be 3,000. So 6 to the 5 times this answer, the whole thing, though, to the 5 times that answer is supposed to make 3,000. So since I'm just going to leave it as a decimal, first thing, if I'm going to check it, I'm going to go times 5. And then I'm going to go 6 to that power, just to check. 6 to that last answer. And I should get 3,000. And that's because I'm using all the decimals that are still in the calculator. If I just did 6 to the, well, let's go 5 times my rounded part, 5 times the rounded answer, 0.894. So 4.47. And then 6 to that power. Don't get 3,000. Hey, it's close, but I'm using rounded values as it happens. So that is 56, 2, 16. Things ain't like the other two. Little Sesame Street. Tell me which one. One of those things is not like the other two. Nope. HC2. The HC2 is different than 56 and 68 because 56, right here, the base is 6. There's nothing else base 6. On 68, parentheses, this is the entire base to a 3T. There's all you have over here is the base of whatever this is. But on 62, the base is E, and you have 1,000 times this base E. 1,000 has nothing to do with that base. Nothing. So there's a little difference is 62, 1,000 times E to the negative 4x equals 75. First thing you should do is divide by the 1,000. Because this is multiplication, divide by the 1,000. You want to get x by itself, so the first thing you have to do is isolate the exponent part of it. Can't divide by 6 because the base is 6. Now, if there was 2 times 6 e to the 5x, I could divide by the 2 because 2 is not part of the base. If it was 3 out in here times this base, then I could divide both sides by 3. Because I have a 3 times that base. I have a 2 times that base. I have 1,000 times that base. It's exactly like if you had 4x squared equal to 20. Well, you don't want to take the square root of both sides until you isolate the x squared. Get the x squared by itself before you take the square root. Now take the square root. Okay? So now, we clean up it. Now, e to the negative 4x is equal to, oh, I can simplify this. This is 3 times 25. And you know, this right here is 250 times 4. And that's 25 times 10 times 4. So technically, it's 40 times 25. So this is 340. If you leave it as 75 over 1,000, that's fine on a homework question like this. But the smaller or the nicer you can make your fractions when you're working with them, when you got to plug them in, it's easier, better. Now to get x. It's an exponent, so we have to undo the power. Only way to do that is a logarithm. Since it's base e, what logarithm should we use? So should do a natural log. You could do log base 10, but you'd have more steps to it. But if I take the natural log over here, you could do the whole Price is Right, come on down. But you know what? Natural log of e to the 4x is just negative 4x. It's the third property of logarithms. Property 3 says log base b of b to the x is just x. If the base of the logarithm is the same as the base of the exponent on the inside, if the bases are the same, they undo each other, you just get x. For natural logarithms, it's natural log, and inside you have an e to the x. So the base of the natural log is an e. Inside you have a base e. Since the bases are the same, they undo each other, you just get whatever that exponent is. So again, on your review sheet, the third page of your review sheet, right here, the natural log of e to the x is just x. The natural log of e to the negative 4x is just negative 4x. So what we're going to do now is you're going to end up finding this natural logarithm of the 3 over 40, and then you'll divide both sides by negative 4. So you're going to want to get this decimal and then divide it by negative 4. Natural log, and we have 3 over 40. Close parentheses. So in the numerator, it is negative 2.590267.165. And down below, we still have negative 4. Is my answer going to be a negative or a positive? It's going to be a positive. If you don't trust yourself to remember that, then when you divide, make sure you put the negative forward. Negative 4. So the answer is 0.64756. 667914. 3 decimal places, 0.648. Now, I'm going to ask you this. For the sake of time, I did this at the end of the co-rec this morning. You are more than welcome to say, all right, let's do whatever you want to ask me to do. And we'll look at this in the co-rec. It's just the last part of the co-rec video that we'll post on. It's there. The co-rec Monday, Wednesday playlist for co-rec. You can ask me whatever you want to ask. It's just simplify what's in here. 16 point something. Take log base 10 or log base u both sides and do the decimal. I'm not going to ask you anything like this involved unless it's a bonus question. There are so many steps to it. It's going to cause so much anxiety trying to get through this if it's an actual test question. I will keep it right about here, even as a bonus question. Just because of the anxiety it sets up. Okay. So if you want to see this one, Monday, Wednesday, today's co-rec, this is there. I want to do 104 and then whatever else you want to ask before we do the quiz. I also don't want to lull you guys to sleep, and it's like, right, too late. Log base 12 of x squared equals 6. And then round the result to 3 decimal places. Verify the answers. If I'm going to solve this, I'm probably going to rewrite it without a logarithm, which means I'm going to do base to the across equals what's inside. Log base 12 of x squared equals 6. So base to the across equals what's inside. What do I get? 12 to the 6th equals x squared. You know, when we solve stuff like this, we probably prefer to write it left to right. X squared equals 12 to the 6th. We just came from a place called quadratic equations. And when we have perfect squares, we would do what to solve them? Take square root of those. So x is equal to, now in terms of plus or minus, remember you cannot have negatives in here. But we'll come back and talk about that in a minute. Square root of 12 to the 6th. Now, you could raise 12 to the 6th power and then take the square root of that. Or you could, yeah, again. I got to figure out something here. You know, that new building over there, they have chairs that are like, well, retail, like over $1,000 each for these little chairs, office chairs. I don't know what they district got in terms of a deal. I'm sitting there and going, wow, I wanted one of these at home. So I looked it up and going, no, I don't. You know, but can't get a camera price. Or at least it keeps people thinking those. So we can raise it to the 6th and then take the square root. Or you could take the square root of 12 and then raise it to the 6th, because that's the rule of exponents. A to the m over n is the nth root of a to the m, or it's the nth root of a, then you raise it to the m. Or how about this? A square root of a is a to what actual power? 1 over what? 1 over 2. 1 over 2. It's a half power. A square root is a 1/2 power. You need to remember that. Just need to know. You need to know square root is a 1/2. Cube root, 1/3. Fourth root, 1/4. So this right here is 12 to the 6th. Square root is a 1/2 power. Now it's the second rule of exponents. The second rule of exponents says a to the m raised to the nth power. Power to a power, you multiply. Multiply the exponent. So this is 12 to the 6th times 1/2. Or how about if you flip it or switch the order? What's 1/2 of 6? we get 3. This is 12 to the third. So 12 times 12 times 12. I know 12 times 12 times 12 is 4, but my powers of 12, I wonder if I ever gave myself something with the powers of all the numbers. What would that be? Oh, I think I put it over here. The perfect powers of 12 to the third, 1,728. Because we took a square root, plus or minus. Since it's raised to the 6, it would be a positive square root of it, plus or minus. If I plug in a positive, then that's a positive. If I plugged in a negative and I squared it first, it would be a positive anyway. So it could be a plus or minus. Because I'm squaring it before I take the logarithm. Okay, so plus or minus will be okay. But it all boiled down to laws or rules of exponents again. Is what your test will look like. Now, I haven't rewritten this year's version of it. It'll basically look something like that. First of all, you were supposed to pick up the review sheet. You're supposed to pick up the review sheet at the back of the room on Monday. If you didn't pick one up, they're up here. So grab one later. This is the review sheet. It's got 50 problems on it. There's not 50 test questions, but it's examples of a whole bunch of different kinds of questions. The first 5 right here are your long divisions and synthetic division examples. Then the rest, it's all jumbled. It's not going to be in the same order as you see on the review sheet. This is what it looks like on the test. So you have 2 long division questions. One where it's nice for you. Everything is in the right order. There's no missing exponents. It's all good to go. But you have to do long division. Then the second long division, maybe it's missing a power, or maybe it's out of order. Not both. One or the other. Then synthetic division. Everything's nice and set up and in the right order, all the powers in it. And then another synthetic division where maybe it's missing a power or maybe it's out of order. Okay. And then approximate the number using a calculator, 4 decimal places here. Approximate the logarithm, 4 decimal places. Equivalent expression in exponential form. Write an equivalent expression, change it to an exponent. I wonder if that would be base to the across equals left and side. Yep, that's what it is. Write it as an exponent. Base to the across equals left and side. Yeah. That's what it is. Write it in log form. That would be going the other way. Solve each equation. Exact value, no decimal. Now, these two, 17 and 18, write the expression as a sum, difference, or product of logarithms. That's this. That's these guys. Sum, difference, property. Split it up with multiplication, split it with addition. Division, use subtraction. Power rule, come on down. You're going to rewrite it. And here you put it back together. These will be multiple choice friendly. I've always given these as you got to write it out, and it just becomes a little too confusing, especially with handwriting. So what I've done is I've changed those two questions, 17 and 18, into multiple choice. And it's also nice because on the review sheet, you have examples of those. 31 through 34 as multiple choice. Now, on the review sheet, I want to apologize. Number 34. What do you notice about number 34? Notice about number 34. Do the same thing. So the test generator that I used to make this review sheet, I guess I didn't read the fine print. But yeah. Just the answer is pick one. Want to see their B or D's to go together. But that's how your question on the test will look like. It won't look like one where you have the same answer on each, but it'll be multiple. And then 19 through 22. Solve the equation. You're going to round to the nearest thousandth on 19, 20, and then 21 and 22, exact value, no decimal. So the review sheet will show you leading through a bunch of examples that look like. One last little thing is you have 8 bonus questions. Now, that's because a lot of these test questions are going to take you, well, it depends. Some of you are going to finish very quickly, but there's 8 bonus questions. Lots of opportunity. The first 2, I haven't decided what to make those, but look at the directions on number 3. Solve using completing the square or quadratic formula method. That shall work. Solve, you must show appropriate work. Solve the equation. Simplified exact value, no decimal. Solve the equation. And then the last 2. Use long division to divide, use synthetic division to divide. So on the last 2, they will probably be mixed up and missing columns. Okay. I can't change the denominator on the synthetic division. It has to be an x minus k. So I can't give you an x squared down there. But on number 7, long division, I can give you any power in the denominator as long as it's less than the numerator. And it can be all scrambled, it can be missing powers, and just like the homework from 3.3.
So from chapter 3, it's just synthetic and logarithm. The final focus, this is what's going to post. This is the 32-page version because it's 1 page per page. And this is what the 16-page version looks like. It's 2 pages per page. You don't have to print it. You don't have to turn it in, but this is what you want to focus on. And if you're going to do them, ask questions, office hours. If you want to ask questions on Monday, that's fine. That's all I need. Not me, you. Okay. Now there's some of these, let me see. Like, and I'll tell you which ones. I'm not going to ask you anything like number 25. I will tell you which one to ignore. But we didn't do anything like number 25, so I wouldn't ask you anything like number 25. Okay? I'll let you know. So we have 10 minutes before the quiz. What do you want to see? Is there anything you want to ask me? 5/8. Same way as I was in 8th grade. Probably Pink Floyd, then the Who, or they will switch, and then the Beatles. Right? I'm just getting random answers out there. 2 kids, 1 grandchild. Well, 2 granddaughters. Dawson 1200, 1972, Dawson 1200. Which one?
Back of the bundle.
Yeah.
4.2.
4.2, which one?
Number 37.
37. So, the properties to simplify. Okay, sharpen your pencil. The answer is 3x. Log base 4, log, and here's, and you're going to hear yourself say it because that'll hopefully trigger what you're supposed to do. Log base 4, and inside is 4 to the 3x. Log base 4, 4 to the 3x. Log base b of b to the x. The base of the logarithm is the same as the base that's inside. Base is 4, inside is base 4. So they undo each other. You get exactly whatever that power is. So they just undo each other. And you can see the word cancel out, but it's not really canceling. Canceling means 5 minus 5. That cancels out. Or log base 4 of 4 to the 3x. I don't know, what does that equal? I don't know. Unfortunately, we usually say, what does that equal? Let's call it x. We already have it. Equals p, whatever. Base to the across. 4 to this equals what's inside. So what we're trying to figure out is that 3x. 4 to what equals 4 to that 3x? It has to be a 3x. So they undo each other. It's recognizing the property. And then the clue right here, use the properties of logarithms. Two point 3.5. Synthetic. So we're synthetic. So I'm going to look at them here. is in order, X to the third, X to the second, X to the first, X to 0. So it is in order. And that is X to the 1 times X to the first, so that's good. So we are dealing with. Oh, so So all the powers are there and it's in the right order. We're dividing by X. Remember, this is X minus K. So what does K equal here? Positive 3. So we draw the box. We put K in the box. K is a positive 3. We list the coefficients of the dividend only. So the coefficients are 6, 7. That's a negative 1. And then a 26. That's negative 1 times X. And then we draw that line. We bring down the first coefficient, bring the 6 straight on down. And then you multiply and then add. 6 times 3. We get 18. And then we add 7 plus 18. This is 25. 25 times 3 is 75. Negative 1 plus 75 is 74. And then we multiply 74 times 3. That's 210 plus 12, so that's 222. All right. Well, okay, 121 plus 1.2. And then we add. And 6 and 2 is 8, and 4 and 248. The last number is the remainder. We started with X to the third, so this is going to start with X to the second. 6 X to the second plus 25 X to the first plus 74 plus the remainder 248 over the divisor X minus 3. That's it. I asked you this question. You again, you should be done with it. All about recognition. Not recognition in terms of like you win something. Recognition is I recognize something. And have you recognized something that we just did 4.5 minutes ago? What do you recognize on the right hand side? What's that? The natural logarithm, but what else too? What is that natural logarithm? Is it a base? Is it a power? It's a power, natural logarithm power. But what's the base of it? E. So what do you know if the base and the power have What do you know about the base of the exponent and the base of the logarithm being the same? They undo each other, yeah. So it's the other part of this. If the natural log of e to the x, base of the natural log is e, inside you have an exponent base e, they undo each other, you just get x. It's just this rule. E to the natural log of x. The base of the exponent is e raised to a power natural log, which is base e. They undo each other, you just get x. So since this is a base e raised to a natural log, this is just 3x minus 4. They undo each other on the right hand side. So now add 4. You get 16 equals 3x divided by 3. X is equal to 1603. That's why when this is ringing the bell for you, and maybe you've had a rough semester up until, and right now it's like, wow, okay. Some people really get into this because they just see it. It's like, why couldn't we have started the year with this? Well, a lot of it had to do with knowing the rules of exponents to begin with. All right, you need a full piece of paper, not a half sheet. And if you need a piece of paper that's not frayed edges, then please, in the back of the room,